Hi everyone, welcome back to the video. This video is going to be the part one of a two-part series where we learn about how we can manage TLS certificates in Kubernetes. So in this part, we are going to talk about the theory and we will start from the basics. So we will literally start from HTTP connection, then we'll talk about the HTTPS connection, what is TLS, what is this TCP connection, etc. We'll talk about these certificate authorities and all. And then I'll also give a brief introduction about how we can manage TLS certificates in Kubernetes. So this part is going to be theory. And in the next video, we'll look into the hands-on. So we will see how we can manage TLS certificates, how we can create these new users, and how we can create roles, how we can bind those roles, and how we can change our context between these users, and how we can ensure that the new user is able to access our cluster and have limited access to our cluster. So let's start with the theory first. So we'll go to the HTTP connection first. So this is the HTTP connection, and I think everybody knows about this. There is this client and there is this server. So a client sends a request to the server and the server sends back a response. Now this is the way very basic communication happens. And whenever we create a project of our own that we are using localhost for viewing that particular project, then it is an HTTP connection. Now it is perfectly fine if we are using it for our own use. So we can create this, like we can create any web server and we can use our local host to access that web server. But this is only good for our personal use. We cannot have this HTTP connection in a production grade server. Why? Because it is not secure. So whenever we send a request and whenever we get back a response, this is in the format of plain text. Let me write it here. And even the response is in form of plain text. So there is no encryption, there is no security present in this protocol, because of which it is very easy for anybody to have a look at what that request is, have a look at the communication between the client and the server, as well as manipulate that request or manipulate the response even. So that is where the HTTPS comes in. So we would use HTTPS for any production grade server. So the communication between the client and the server for any website that is secure in the web is HTTPS. So HTTPS basically is a secure protocol. And what it does is it uses this encryption mechanism, which is called SSL or which is called TLS. So SSL is the older version and TLS is the newer version that is being used. I have written SSL here. Both are essentially the same. Both have the same goal basically to encrypt the messages, to encrypt the communication that happens between the client and that happens between the server. So SSL stands for Secure Sockets Layer, and the successor to SSL is TLS, which stands for Transport Layer Security. So these are basically cryptographic protocols that will secure the communication that happens between this client and the server. So they will basically encrypt the data that goes from the client and then decrypt it at the server level. So this basically helps in securing the data from interception or tampering. Interception is when a hacker or somebody will be able to read the communication that happens between our client and server. And tampering is basically when he or she tries to change the data that is being communicated. So that is how HTTPS works. HTTPS uses this SSL protocol so that the communication between this client and the server is safe. So let us have a look at how the HTTPS connection looks. So this is how the HTTPS TLS connection looks like. And I tried making a few diagrams like these, but uh, I could not get a more detailed diagram and I thought I should simply take it. So before we talk about this, I want to share that I have taken this diagram from a YouTube video. So I actually tried creating these diagrams and all. I thought it was really cumbersome. I thought it was really time taking, and the diagrams I found on the web were not very well explained. I think this is really good diagram. I have taken it from this video. The channel is Learn with GVR, and I will also link this video on the description so you can check it out if you want to. So this is how the diagram looks like for HTTPS connection. So if you are wondering what TLS is, then TLS basically is transport layer protocol. So it basically ensures that the data is being transferred from this client and the server, from the client to the server, and it is encrypted in middle. So what HTTPS does is HTTPS works on the top of TLS. Let's see how the communication happens. So whenever we type a URL in our browser, for example, I will say github.com, then there is this DNS resolution process that happens so that we can find out the IP address for this domain name basically. So the DNS resolution, DNS basically is domain name system. So it is like a phone book of the internet. It is, it will do what? It will take this github.com and find the corresponding IP address to this github.com. And the process of doing that is called DNS resolution. So how that basically works is that firstly, we will check the browser cache data. Firstly, we will check the browser cache data. So if we have used github.com before this, then it will be stored in form of cache in our browser, or if not in browser, then we will check the OS cache data. And then we will go to the recursive resolver to figure out what the IP address is. So that is a very, I think that is a different video altogether. But the basic idea is that for this domain name, we will try to find out the IP address. So that's what we mean by DNS resolution. Once we have the IP address, the next step is to establish a TCP connection. Now, how the TCP connection works is, let me show this diagram. TCP connection, and this diagram also I have taken from the same YouTube channel, which is Learn with GVR. So let me go back here. How this basically works is this, there is this TCP connection that is established between the web browser and the web server. So like I have written the steps here as well. So what browser does is browser will send this synchronization packet to the server, and you can see that the synchronization is 1 and the acknowledgement is 0. So the next step would be that the server, here I've taken the example of Google. So the server will respond to this with an acknowledgement package. So now that the server has acknowledged, we have sync is equals to 1 and acknowledgement is equals to 1. Also, you'll see that there is this number we have sent. The web browser will send in the first step, web browser will send this number to the web server, and the web server will simply add 1 or increment this by 1 and send it back. And then in the third one, browser will acknowledge this acknowledgement package, and that is where the TCP connection will be established. And yes, this is very important. This is TCP handshake, and do not confuse it with TLS handshake. We'll talk about TLS handshake next. Let's go back here. So we talked about this TCP connection, establishing this TCP connection. And the next step would be the TLS handshake. Let's go back here. And this is how the TLS handshake looks like. So this is also taken from the same video. Link is in the description. And this is how the TLS handshake basically works. So I've also written the steps that will be really helpful. Uh, yes. So the first step is that the client will send a client hello. The web browser will send a client hello to the web server, which will include this message client hello, and this will try to initiate the handshake. This would also include a client random, which is like a random value generated by client. Then the server will respond with a server hello message, and this would include another random value generated by the server. Now, as we have written here, certificate transmission. So after this server is sending this After the server has sent this server hello message, server will also send a certificate. The certificate will contain server's public key and it will be signed by a trusted CA authority. So we'll look into this in this diagram. Let me show you just the basic overview. So the client sends hello, the server will send a hello message, server will send a certificate, and server will also request for client certificate. The client will send a certificate, and then the client send this cryptographic hash value, and the server is finished, the client is finished, as in the communication between from the client and the server is finished, and the communications from here on will be encrypted. So let us go back to this part. So how this basically works is that the step one, as we have written, is the certificate authority gives a public certificate to the client. So how this basically works is, like we said, first step was the client sends client hello, server sends server hello, and then the server sends a server certificate, and it will also demand for client certificate. So how the verification process happens basically is that, like we have said, first step is that that the certificate authority will send a public certificate to the client. So this is like this. So this certificate is present in our browser itself, and we will also have this. The server will also have this certificate that was signed by the certificate authority. Then what happens is the client requests for the certificate and the server sends the certificate and the public key. So what basically happens is the client will verify that the certificate was issued by a trusted certificate authority. There are a few trusted certificate authorities like DigiCert or Komodo, etc. GoDaddy is also another certificate authority. So yes, the client basically verifies that the certificate that the server gave was issued by a trusted certificate authority. And the next step is that the client will ensure that this certificate is valid and this certificate is for the requested domain only. Like we went into github.com, the client will make sure that the certificate is from, like the certificate is provided to the github.com by the certificate authority. The next step, then the client will check the validity period, making sure that it is not expired. And then the client will also ensure that the certificate authority signature on that particular certificate is valid by the help of this public key. So, like we said, firstly, there is this certificate present in the client, then there is this certificate and private key present in the server. The server will send a certificate and a public key to the client. And this was step 4, I think. Server sends certificate and public key to the client. Step 4. Step 5 is that the client will check if the certificate is correct or not. Step 6. Now, once client has verified, okay, this server is authenticated and this server is the real github.com, then at that point, the client will basically send the encrypted session key, and this session key will be used for the communication, for encrypted communication between the client and the server. So the step 6 is that the client sends this encrypted session key to the server. Actually, the uh, session key is derived by client and server both together. What actually happens is that the client sends finishing messages, like some message which is encrypted by the session key, and the server sends back this acknowledgement which is encrypted by session key. So I think the step 6 should be client send encrypted session key. I think this should be client sends a message encrypted by session key. And then the server sends an acknowledgement which is encrypted by session key. This is done so that we can ensure that the session key is the same for both the client and the server. And once we have ensured that both sides have the same session key, then all the data or all the communication that happens between this client and the server will be encrypted by this session key. So I think this is one minor mistake here, that it should be client send data encrypted by session key. So this is how the TLS handshake basically works. So we looked into DNS resolution. We talked about the establishment of this TCP connection. Then happens the TLS handshake. Once the TLS handshake is completed, all the data will be encrypted now. So now we can send this HTTPS requests. So now the client will send a HTTPS request to the server, and the server will basically respond to that particular request, and then the server will render the web page, and then the caching and session etc happens. That is a different thing. So i think that is uh, I think that is it. We wanted to cover about the TCP connection, about the TLS handshake etc. Now we will look into, so yes, this is another thing. I think we have covered this as well, and we have covered this as well. So that's all I wanted to talk about here. Next, we will look into the Kubernetes documentation. So let's say kubernetes.io, and we will type certificate here, certificate and certificate signing requests. So now we will talk about this thing, how to issue a certificate for a user. So this is the complete hands-on part where we are going to issue a certificate for a user. Not just that, we will also create these roles and etc. So this hands-on will be done in the next video. So one thing that we did not cover, which is the most important thing actually, that how communication happens between components in Kubernetes. So we talked about how the communication will happen in the case of a user and like a client and a server, how the communication happens in Kubernetes cluster. So it is quite the same. The communication happens through the HTTPS only. The only difference is that in Kubernetes, the components will become client as well as the server. So if you look at this kube API server, what happens is whenever we write a kubectl command, it goes to the kube API server. So if we are writing a command, then we are a client, or the machine is the client, and the kube API server is the server here. But if kube API server is requesting something from the etcd, then the kube API server becomes the client and the etcd becomes the server. So this is how it basically works. All the components you are seeing here are server as well as they are client. And all the communication that happens between these components is secured. So even for the Kubernetes cluster, we will have this certificate authority. Rather than using a public certificate authority, we will use an internal certificate authority for Kubernetes, because unlike in public certificate authority where it was telling us, yes, this is the github.com we are talking about, here the use case is different. Here the use case would be that let us say we have a user, then that particular user has access to the cluster or not. That is what we will check through certificates, and that is what will be issued by the certificate authority. So if there is a new user, we have to make sure that the new user has access to the kubectl. At that time, we will use this certificate authority. We will create these uh, certificate signing request, etc., and we will provide the access to the user. And then whenever the user will type, or whenever we type these kubectl commands, then actually the Kubernetes is checking, okay, does this person have the authority or not? So that is how internal certificate authority works in Kubernetes. I can understand that this may be a little bit confusing right now, but when we do the hands-on, I am pretty sure you will be able to understand this concept very clearly. So for now, just think that there is this, like we had with this HTTPS connection, there is this certificate authority. Similarly, in Kubernetes also, we will have this certificate authority, which is not public certificate authority, which is like an internal certificate authority of the cluster, and which will make sure that if there is a new user that is coming to our cluster, then only the access we are providing to that user should be given to that user. And if that user is not having all the certificate signing request and the public key, etc., then the user will not be allowed to access the cluster. So I think that is it for this video. So the next video is going to be about hands-on on this, how to create, how to issue the certificate for a user. We'll also look into these roles, role bindings, etc. So I hope you watch that video. That will really help you understand the entire concept. But in either case, thank you for watching this video, and I'll see you in the next one.